All right, picking up where we left off with question 5. Chapter 6 is where we're at. So what is the formula mass of iron 2 chloride? Now, I want to point out that just because it's iron 2 versus iron 3 does not change its mass, okay? Because electrons weigh almost nothing. So that difference of one electron or the other, iron 2 versus iron 3, really makes no difference whatsoever. So when I go to the periodic table, I can just use the mass of iron regardless of whether it's iron 2 or iron 3. So go ahead and give this video a pause, see if you can calculate the mass, and then come back. All right, so assuming you've done the work, let's go into it. So we're going to calculate the mass of iron 2 chloride. So our formula will be FeCl2. Because it's iron 2 chloride, I need 2 chlorines to go with it. This is where we're building on your skills with nomenclature. Okay, it's very important. So I have 1 iron. So 1 times 55.85 AMU. And 2 chlorines, so 2 times 35.45 AMU. And so the numbers come out this way, and so we're going to add those together, and we come up with 126.75 AMU. Right, so it's our third answer on the list. AMU, or units, atomic mass units. Okay, so our new concept here, the mole concept. Okay, and if you took notes either in class or in a Zoom meeting, then the mole is something that should be fairly familiar to you. And the point about the mole is that it is a counting unit. It's a counting number. Okay, not a counting hashtag, but a counting number. Okay, just like I would say 1 dozen, 1 dozen donuts, and I'm not going to spell donuts correctly, equals 12 donuts, right? Right? A dozen is a counting unit, just like the mole is. Okay, so I can say that a mole of something is 6.02 times 10 to the 23rd of that thing. Okay, so I can have a mole of marbles, or a mole of leaves on trees, or a mole of cats. It really doesn't matter. But the mole is a counting unit because atoms and molecules are so small, right? Very, very small particles. And so in order to deal with those tiny particles in units that we can deal with, in terms of grams or like things we can put on a balance, we need a counting unit that is appropriate for the massive number of particles, atoms or molecules, that we are dealing with. So when we say particles in this slide, pretty much we're talking about molecules or atoms. Okay? So particles being whole molecules or individual atoms, doesn't really matter. But a mole of atoms is 6.02 times 10 to the 23rd atoms, or a mole of molecules is 6.02 times 10 to the 23rd molecules. Okay? And this ends up being a conversion factor for us. So what, for example, 1 mole of atoms is 6.02 times 10 to the 23rd atoms. Okay, or I could say 1 mole of molecules is that many molecules. Okay, so this is a conversion factor for us. And that's very important because if it's a conversion factor, I can flip it to put Avogadro's number on the top and moles on the bottom, or moles on the bottom and Avogadro's number on the top. Okay, and I should have mentioned that, if you missed that in the lecture, that number, 6.02 times 10 to the 23rd, is called Avogadro's number. Okay, named after the Italian mathematician Amedeo Avogadro. Right? So we're going to use this as a conversion factor whenever we have to go between number of atoms or molecules and moles. Okay, so the important parts about that are moles and particles. Okay, atoms or molecules. So when we take that to the next step, when we look at the periodic table, and say, for example, in this slide, we're looking at carbon, we have this number here, 12.01, right? And so one atom of carbon is 12.01 atomic mass units. But when we scale it up to masses, or moles, one mole of carbon weighs 12.01 grams. Okay, so when we look on the periodic table, the numbers are the same, but the units become more useful, right? So 12.01 grams per mole is more useful to us because we can put, things on a balance like it shows in this image and weigh out 12.01 grams of carbon and know that that is 1 mole of carbon atoms. Okay? So now we have several different ways to relate things, right? And the important ones are, how do we relate to moles? We have a couple of different ways to do that now. We have grams to moles, and we have particles to moles, and particles is related through Avogadro and his number. Right? And grams to moles comes from the periodic table. Okay, and then in a reaction, and we'll get to this later in the chapter, we can relate moles of one thing to moles of another thing. Moles of A to moles of B. Okay, but now we have 2 ways to get to moles, and that's the important part. We can go from grams to moles, or we can go from particles to moles as we need to. Right? And I related to a student earlier today that these things are kind of like tools in a toolbox. Right? Depending on the job that I need to do, I'm going to reach for the particular tool that's going to get that job done. If I need to relate moles and grams, I'm going to reach for molar mass. If I need to relate moles to particles, meaning atoms or molecules, I'm going to reach for Avogadro's number. Those are my tools to grab from. Okay? So let's take a look at this problem. Convert 5.31 grams of calcium to moles. Right? So let's sort of dissect it just a little bit because it's a pretty simple, it's a one-line statement. What do we have here? We have grams and we have moles. Right? So what unit of conversion do we have? Grams and moles is molar mass. And we get that from the periodic table. Okay, so if I have 5.31 grams of calcium, I can look on the periodic table, and calcium has a molar mass of 40.08 grams per mole. Okay, and it's also, to back up a little bit, it's also very important to put the number with the grams. So 40.08 belongs with the grams. And it helps to actually say it out loud to yourself. 40.08 grams per mole. Okay? So a common mistake is to put the number with the moles, and that's incorrect. Okay, so this becomes our conversion factor. So I'm going to do this just like every other conversion problem we've done so far this semester. I'm going to start with my given information, 5.31 grams of calcium. And I'm going to write my conversion factor so that the grams cancel out. So I'm going to put 40.08 grams of calcium on the bottom and moles of calcium on the top. So if I cancel out my grams, that means that I should have an answer in moles of calcium to finish. And we should come out to be 0.132 moles of calcium. And that really should just be Ca. All right, let's look at our next problem. So let's convert moles of lithium to grams. And so dissecting the words a little bit, what do we have in the problem? We have moles, and then we have grams. That tells us that we're going to use molar mass. Right, because the units of molar mass are grams and moles. Right, so if we look up lithium on the periodic table, we find that it is 6.94 grams per mole. So 6.94 grams of lithium per mole of lithium. So let's go ahead and put that in there. Right, so I'm going to treat this like every other conversion factor problem. So I'm going to start with my given information. And then we're going to use the conversion factor to make moles of lithium cancel out. So 6.94 grams of lithium per mole of lithium. All right, so our moles of lithium will cancel each other out, leaving us with an answer that is grams of lithium. And will come out to be 626 grams of lithium. All right, let's see how we did. So 0.132 moles of calcium and 626 grams of lithium. All right, so I'm going to go ahead and stop this video right here. We'll pick it up right here on the next video.